The nearest star to Earth that isn't the sun is 25 trillion miles away. But we've never been there and we don't have rulers that go that far, so how do we really know? Well, the answer lies in how our brains find distance every single day. So try this. Place one finger right between your eyes. Now close one eye and notice where your finger appears on the background. Then switch which eye is open. Did you see the difference? Now try it one more time with your finger at arm's length. There's still a shift, but it's smaller. Now our brains use the 6 centimeter distance between our eyes and the difference in how each eye sees an object to find out how far away that object is. The bigger the shift, the closer the object. The smaller the shift, the further away. And this is called depth perception. But what does this have to do with finding the distance to stars? Well, stars are too far away for you to change which eye is open and see a difference in where they're located. But imagine your eyes aren't 6 centimeters apart, but 186 million miles apart. That's what the Earth does every 6 months as it orbits the sun. And computers connected to telescopes can see a star's shift in location compared to the background stars, just like your brain sees your finger changing its location. And this is how we know the distance between Earth and the nearby stars in the night sky. We use the measured shift of the star, and then we use math, more specifically trigonometry. And it becomes a simple equation for astronomers. To date, we've found the distance to over 1.3 billion objects in space, up to 66,000 light years away. Stars that are further than that will need a different method to find their distance, because that shift gets too small. This is called using parallax to find star distance. And I'll explain later how it fundamentally changed our understanding of the universe. But here's when things get really interesting, because it turns out that there are two types of parallax. Static parallax is where you look at an object from different locations and its background changes, like with stars or your finger. The second is when you're looking at an object and you're in constant motion, like in a train or a car. The farther something is away from you, the less it appears to change position. You'll notice close objects like trees or buildings move by you quickly. And the planets and stars, which are about as far away from you as anything can get, well, they don't appear to move at all, which can lead to an eerie phenomena that people have reported seeing. Sometimes at night, on dark roads in the middle of nowhere, bright lights in the sky can look like they are following you, and your imagination can run wild. I mean, is it a UFO, or is it something different? Did a UFO travel trillions and trillions of miles over enormous periods of time to mess with you on a highway? Or is it Venus, the brightest object in the sky, its movements explained by motion parallax? Occam's razor says that it's Venus, but if you want to argue with me, feel free to go ahead and do that in the comments. And this brings me to a big mistake that sci-fi movies tend to make, because if a spaceship were traveling at the speed of light or some enormous speed, stars wouldn't fly by like they do in the movies. The nearby stars would appear to go by you kind of slowly, but stars in the distance would pretty much stay exactly where they are. Movies make it look so much more exciting than it actually would be. And now it's time for a bird bite. Some animals, like pigeons, have a hard time with depth perception because their eyes are pointing in different directions. So you'll often see them bobbing their heads, looking at something from different perspectives. And guess how much each bob moves their head? Well, it's about 5 centimeters. Do you remember how far apart our eyes are? 6 centimeters. Is it a coincidence? So this is how pigeons get their depth perception. It's so cool. We always knew the universe was big, but when we first used parallax to find the distance to nearby stars in 1838, it changed how humans saw their place in the heavens. Take Proxima Centauri, for example. It's only 4.2 light years from Earth, but that's 25 trillion miles away. But we don't really use miles in space. That would be like using inches to measure the distance between here and Paris, France. It just doesn't make sense. Light years, the distance that light travels in a year, are much better. And at the speed of today's spacecraft, it would take like 75,000 years to get to Proxima Centauri. Space is enormous. So parallax is everywhere, explaining the mysterious to the mundane. And if we understand it, we can measure the distance to stars, we can stop arguing over the existence of prankster aliens in the middle of nowhere, and we can understand why doing something with one eye is so difficult. And really, any phenomena that can explain why pigeons bob their head and how we map out the universe is a pretty remarkable one. So if you enjoyed this video, like it and subscribe to the channel. And until next time, stay curious.